Okay, class, this is Miss Cash. I just wanted to do a couple of example problems for you so you know what I'm asking you to do. So you remember a couple days ago we saw that you do not have to know how to solve using algebra. You can solve using a graph. I'm not going to do every single one, but I'll work number 7 and number 16 for you here today. Looking at number 7, all we're going to do is we're going to put the left-hand side in y1. So second square root of x. Notice that that minus 3 is not under the square root, so I'm going to arrow over and then do minus 3. Then it equals 7. When I go look at that graph, you probably notice they don't seem to cross. But if I go way, way out, they might. You are going to have to adjust your window sometimes. If you're not sure where, take a guess. I can see it looks like it's way far off, so I'm going to guess. The only thing that needs to increase is my x, because that's to the right, my x max, and I'm going to say 150. Just a guess. I'm going to look at that graph and see if I can see now where they cross. I went big enough, but not too big. I can see exactly where they cross. So I'm going to use second calc, intersect number 5, and enter 3 times. That will give me my intersection, I know it's in the glare there, of 100 for the x, 7 for the y. So what I had asked that you do was sketch the graph for me. Now I know that this graph here doesn't have 100 spaces on it, but on a sketch, doesn't really matter. It does start down here at -3, and I can kind of curve it up. And then I have a flat line across. And I do know that the intersection is at 100,7, so I am going to label the intersection. And then when I go to write my answer, I'm going to write that x equals 100. Because I only care about the x value since x was all that was in the problem. Looking at number 16, if you need to look at that more, you can pause it. But looking at number 16, I'm going to do the same idea. I'm going to go back to my y equals and graph this. Square plus 5 in one of them equals 4, so 4 in the next one. And then I'm going to hit, oh, my graph is way off right now. Let's zoom 6 to get back to a standard graph. And there is my graph. Notice that the red line stays well below the blue parabola the entire time. So I would make a graph of that, a sketch of that. The parabola comes only down to 5. You guys should know this from knowing about transformations, right? This moved the vertex of the parabola up 5. And then the line comes right across at 4, so they never cross, which tells us that it has no real solutions. We do have imaginary solutions, but I haven't asked you for those right now. So at least according to the graph, there are no real solutions. You could use the root finder if you wanted to find the real solutions. All right, that's it for that side. I think you can do the other 18 of those problems there. You do have some graph paper that the sub has to hand out. So looking at the next piece. I'm going to look at the back side of this worksheet, and this is what we looked at in class yesterday. We didn't do ones quite this complicated, but again, we're going to use the calculator to help us out. So if we go into the y equals, and we put this, what's on the left of the inequality, in y1. Remember, absolute value is alpha window number 1. We're going to replace m with x, but that's okay. We've been doing that forever. And we're going to put 24 here. Now, we're not worried about the less than sign yet. We will when we look at the graph. Notice that y is 24 here. So I probably know that I need to go bigger than 24. So if I go to my window, my y max needs to be bigger than that so I can see it. So let's make it 30. Now I'm going to graph it. Okay, I can see that I have a V shape. I can see that I have two intersections. Those are my boundary points. So let's find the boundary points. Second calc intersect, enter, enter, enter. So my first boundary point is at x equals 1. I'm going to come here and circle that. And then second boundary point, second calc, intersect again, enter, enter, but this time bring my spider over to this intersection before I enter, and I have a -1 as my other intersection. So there's my two intersections. I've circled them. Think for a second, why did I not fill those circles in? Hopefully by now we talked about the fact that you don't fill the circles in if it's less than. You do fill the circles in if you have something that says less than or greater than or equal to, if it has the line underneath. It's no line, no fill in. Last thing we need to know is, should we highlight between the two dots or going outward from the two dots? Well, this says less than. Less than looks like an L that's been squashed, right? Take an L, squash it, you get the less than sign. If we need less than, where is the blue less than the red? Well, in the middle, the blue is less than the red. On the ends, it's higher than the red. So for this case, we're going to highlight between the two dots because the middle is the section that was less than. And if we write our answer, we're going to say -1 less than m, because remember we're doing m, not x, less than 1. If m is in the middle, that's the way it works. If we have the two ends, we'll write it differently. But hopefully we looked at that a little bit yesterday, and you guys can work on this now. All right, good luck. If you have any questions, see if Miss Rhodes is around. Go ask her. Work hard. I expect you to finish most of this work today. Thank you. Have a great day.